I'm on my favorite Arch Linux distro right now, and I'm getting ready to log in. So let me go ahead and do that. And let me log into my Arch Linux distribution. It's my daily driver on the laptop. And I'm in the terminal right now. So what I'm going to do is I'm going to go ahead and cd out, and let's see where I'm at right now. I'm in Home Data Pioneer. Data Pioneer is my username on my system. Let me clear the screen. What I'm going to do first of all is I'm going to log into one of my servers. It's on my Raspberry Pi. I've got several servers running out there. I've got a Node-RED server, SSH daemon server. I've got a very secure FTP daemon server, VSFTPD. And I also have a Pi-hole server, and I'll get into some of those later on. But let's go ahead. Let me SSH. The user is Pi, and the IP address of the Pi on the network is 192.168.1.90. So I'm going to SSH as user Pi into 192.168.1.90, and I'm going to go ahead and supply the password. And that's letting me in. So I'm logged in now as the Pi user. Typically, you would not do this for security reasons, but I'm going to go ahead and just elevate my privileges to root user. Because often I forget to sudo, and I have to run the command twice. So I'm just going to go ahead and bypass that. So I am, who am I? I am the root user right now. Where am I? Home Pi. All right. Okay, so let's clear the screen. And, okay, clear. All right, the Raspberry Pi that I'm on right now, and I am logged in as root, as you can see here, and I just proved that a few seconds ago, is running a derivative of Debian Linux, Debian 9, called the Debian Stretch. Actually, the operating system is tailored for the Raspberry Pi, so it's a Raspbian OS, R-A-S-P-B-I-A-N, which is Debian Stretch, basically, a derivation or derivative of Debian 9. And so one of the commands you just saw that you cannot use is CLS, okay? You have to use clear, all right, to clear the screen. That's okay. In Arch Linux, I can use CLS or clear, either one. All right, so the file that actually controls the operation of the SSH daemon server is a file that's out on CD etc SSH, and let me do a long listing of that. And the file is called sshd_config. One of the ways that you can harden your SSH daemon server is to reconfigure rather, or change some of the settings in your SSH_daemon config file. And so let's take a look at that. I'm on the nano end of that. So let's go nano sshd_config. All right, and here it is. And so this is a file that is an daemon_config that is in OpenBSD. All right, and so it is OpenSSH, not really the old SSH you may be used to seeing in Linux, but it's OpenSSH. And so by default, I'm just going to call it SSH, not OpenSSH. All right, so one of the things you can do is obviously you can change the port number that SSH listens to. So one of the ways to harden it is to come down, and down here I can take this pound sign off here for commenting out, and so that when I restart the server, save this file, restart the server, this file will get reread and it will change. One of the things you can do here what most people do is change the port number to like port 222 instead of port 22, or any port really that you want to use. You'd like to keep it below 1024. You could change this port number to 756. I mean, it doesn't matter what port number you give it. A lot of people think that that's a way to secure your SSH. Really isn't. The only advantage you have, I say it isn't because somebody can easily find out which port SSH is listening on by using port sniffer, and so they just sniff it until it sees SSH running on port 756. So it's really not a way to get around a security problem by doing that, but people do it anyway. And for people that may not know that you can use a port sniffer and locate the port that SSH is listening on, wouldn't know, and so that might stop them, but it's not going to stop everybody. So I really don't think that's an advantage here. One of the advantages, however, for changing the port is that you can reduce the amount of logs that are written here in the system on the Pi, or any Linux system for that matter. The amount of information that gets logged in your var log would be reduced. Why? Because a lot of bots write to that log when bots try to log into your SSH server, and so they typically look at port 22. They don't look at anything else, and so if you change the port, you're not going to get a lot of bots that write to it, and so it's one advantage you might have. I'm not going to change it. The reason that I'm not going to change it, obviously, is because I don't want to have to change this port number on the applications that look for SSH. Also, if you change the port number, then you're going to have to notify people outside of your local area network who might want to SSH or might need to SSH into your Pi, or applications that might need to do it. You're going to have to inform them of the changed port number. All right, and so just to leave it at port 22 is fine. Down here, you can even change what address that SSH listens on. I'm not going to modify that either. What I am going to do, though, is I'm going to get down here to an area that that really is a means of securing your SSH server, and that's under your authentication area. One of the things that we can do here, and these are all commented out right now, and the reason they're commented out is because later on I'm going to, in a different video, I'm going to show you an application called Fail to Ban, and it takes into consideration a lot of the restrictions that you could make in this file here. But if you wanted to, you could change the login grace time. It's currently set for 2 minutes if you uncomment this out here and resave the file. The login grace time is the amount of time that a person has to log in once they access your server with an SSH session and start to log in. They have 2 minutes to do the login, or they get locked out and eventually would get banned. And through another file that we'll talk about in another episode of securing your SSH daemon server, which is deny hosts. And so let's look on the rest of this file. Permit root login, prohibit the root password to get logged into SSH. Yeah, that's something you definitely want to do. And that's one of the things that I'm going to look at right now for securing or hardening your SSH daemon, is to not permit root login. And so by uncommenting this line here, I'm saying permit root login, prohibit password. I'm saying prohibit the password for root to log in. So I'm basically saying root cannot log in here. Another way to do it would be to, say permit root login equals no. But by prohibiting the password, I'm doing the same thing. Max authorized retries here, or tries. I could uncomment this out here and change this down to, say, 3, okay, to allow fewer tries of logging into your SSH. But I'm going to take care of that in the fail to ban, so I'm not going to need that. when I show you that later on in another video. So let's go ahead and comment that back out. Max number of sessions 10. I'm going to leave that as the way it is. Let's come on down and let's look at the rest of this file. So one of the ways that we've looked at now hardening the SSH daemon server is to disallow root. And the reason for that, as I mentioned now, and I didn't mention earlier, is that a person does get access to your server. If you prohibit root login, one of the ways that a person's going to, or a hacker is going to try to get into your SSH, obviously, is they're going to try the root user. And if they can get in, then guess what? They have root privileges. They're elevated automatically. So you want to prohibit that. And so let's go on down. One of the other things that we want to look at here is something I added to this file. It wasn't here by default. And that is these 3 lines here. The first line is commented, is allow users and groups. And that's just a comment. Allow users will allow only specific users to log into your SSH daemon server here on the Pi. I mean, for instance, if I had test user as one of the users, and if I had data pioneer as another one that I wanted to specifically allow to log in, and then commented out this line here, and then save the file, restarted, and this file gets reread, then that means that only test user and data pioneer would be able to log in. That would be okay. It would be very secure, as a matter of fact. Nobody else could log into your SSH server. Another problem is I don't like to do it that way. I would rather assign people to groups, and then that way only a member of that group can log in. I think that's a better way of handling it. So let me comment that one out. Let me come down here and let me uncomment this line, and let me change this to admins. Okay, so I'm going to say only members of the admins group are allowed to log in to my SSH server. All right, now I do not currently have Pi user, okay, a member of admins, and so I'm not going to restart the SSH server here until I have completed that process. All right, so let's go ahead and save this file. So let's do a Control-X and yes to save. All right, and so in order to create, first of all, let me look and see if I have an admins group. I don't think I do. And so the file that controls that is, let's cat that file. It's /etc/etc/group. All right, and so right now at the bottom of this file, I do not have an admins group. So let's add that. And so group add is the command we use. All right, and group add and then admins is the group I want to add. All right, and so let's rerun that file and just take a look at etc group. And now I do have an admins group here, okay, assigned in the system or created in the system. And so now what I want to do is I want to take the Pi user and I want to add that Pi user to the admins group. Otherwise, they're not going to be able to log in to SSH. All right, and so let's go ahead and do a user mod, and let's do attack ag. What that little a does is appends the group that I put at the end of this line here for this command as an additional group that this user belongs to, in addition to the general group that they belong to, or the default group, which is the capital G. All right, and so attack ag, and the group is admins. All right, and the user is Pi. All right, so that should add Pi to the appended group of admins. And so let's go ahead and take a look at that. Let's run this command again to look at the group. And so here we have admins, and if we come up and let's look at the Pi user, Pi is here, okay, and so Pi is a member of its own group, Pi, which is 1000. If you come down to admins, however, the admins group, and we have Pi as a member of that group now, which did not exist before. All right, so we've taken care of that. And so now let's go ahead and exit out of here. And I'm going to go ahead and restart the server. And to do that, I'm going to run a service SSH Restart. I'm not root right now, so that's telling me, it's warning me that I'm not root. So let me put down as root. Let me do the password for root. And authentication is complete. So that means it restarted the server. If I want to check the status of that, I can do a service SSH Status. And I can see that the SSH daemon service is active and running. It's also enabled. Okay, so it's going to survive a reboot. And so now I can go ahead and exit out of here. Actually do I've already restarted the SSH daemon server, so I don't need to restart the Pi, but I am going to get out of here, and I close the connection. So I'm now back on my Arch Linux system. So now let's see if I can log in as Pi. And so let's do an SSH Pi at 192.168.1.90, and it's asking for the password. And I was able to log in. All right, so I'm logged back in. So let's try to log in as another user of the system we know that's there, and that is test user, because I had test user up earlier. Let's see if we can get in as test user. All right, so let's go ahead and exit out of here, get back to Arch Linux. Okay, so let's go ahead and see if we can log in as test user. Who's a member, not a member of the admins group, and see if we can get into the SSH server. So let's SSH test user at 192.168.1.90. It's asking for the password. We put the password in. Permission denied. Okay, so let's put it in again. Make sure we typed it right. Permission denied again. All right, so it looks like test user has not been allowed to log into the SSH server because he's not a member of the admins group. So let's try root now, because we also denied root access to the SSH server. So let's do SSH root at 192.168.1.90. And I know what root's password is for sure. Okay, put that in, and permission denied. Let's try it again. Okay, one more time. Okay, so it looks like both test user and root were denied access to the SSH server, which is exactly what we wanted to accomplish. So we've hardened the SSH daemon server by denying root access and by denying any user other than a member of the admins group access to the SSH server. So this has been a video on hardening your SSH daemon server by modifying the sshd_config file. Keep watching. I'm going to add a video to include the deny.host file for hardening the SSH server, and also introduce you to fail to ban. Have a good day.